Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Mondher from University of Technology and Applied Science. This is the first lecture in our course called Object-Oriented Programming, an interesting course. In this course, we will learn some of the basic object-oriented programming concept, which will cover learning outcome number one. This lecture mostly will be theory, but the rest of the course will be practical and all programming. I suppose that you already had some experience in any one of the programming languages. So let's see what we're gonna learn today. Today we will have Assalamu alaikum. This is Dr. Mondher from University of Technology and Applied Science in Ibrahim. Today we will have the first lecture in our course ITSE 203, Object-Oriented Programming, and today we will only focus on the main concept in Object-Oriented Programming, which will cover course learning outcome number one. This lecture will be mostly theory, but the rest of the course is practical. So we have to know some of the terms. We have to know something about object-oriented programming before we start and before we launch our programs. So let's see what we're gonna learn today, inshallah. So the first thing that we will say that we will describe some of the features of Java technology. It's a very interesting language, and we can say it's a new language, but it is used mostly in all fields. Describe some of the concept in object-oriented programming, such as polymorphism, encapsulation, and so on. And also we will have to look at the Java program structure and see how we gonna perform or run Java program, because we will learn object-oriented programming using Java. Also we will look at Java virtual machine, discuss the architecture of Java virtual machine, and see what's the important of having Java virtual machine. We will practice all these things using NetBeans environment. So I suggest you go and install NetBeans environment. It's a very interesting platform that you can run in any language. Maybe you already had this in another course. So first of all, we will compare between what we know as procedural oriented programming, which we call it POP, and object oriented programming structure. Now, if we want to say look at the procedure object oriented programming, I will say POP from now on. So when I say POP, you already know I mean procedure oriented programming. When we talk about POP or POP, we thinking about steps 1, 2, 3, 4, 5, 6, 7, and so on. So we're talking about some of the sequence steps that need to be, performed in order to solve some problems. Okay. Now the main focus in POP is a procedure, or what we call it functions. Each function performs some of the tasks, and also if we need to run this function, we only need to call that function by name. So the main thing in procedure oriented programming is it is focused on process rather than on the data. It was a very good way in the past, and some people still using it for simple programming. Basically, it divides the program into a function, and each function has some method or task to do or purpose to do, and you call this function whenever you need. So the basic all we need to know is that it just stress the code into a coding steps, and also we need to know that it is I'll just highlight this stress the sequence in of coding steps, and also focus on process rather than data, and divide the program into what? Into multiple functions. And now the new approach is called object-oriented programming language or object-oriented programming, which is basically depend on object more than data. So everything in this programming is called object, and we will see what's the meaning of object anyway. So the main focus on this approach is the interaction, creating an interaction between objects. You can see in the diagram here that we have objects. How many objects do we have? And there's interaction between these objects. So we don't have like focus on functions only, or what do we call it, a procedure. We have object. Each object has some properties, has some functions inside it, and they are interact with each other somehow to perform or to solve a problem or even many problems. Now, both of them are considered either object-oriented programming or procedure-oriented programming, or programming per diagram, and you need to think about the only main difference between these two paradigm is that OOB divide the program into object to solve the problem, but POB divide the program into multiple functions or procedure to solve the problem. So this is the main difference. OOB divide the program into multiple objects, but POP here divide the program into what? Multiple procedure and function. This is the main difference between them. Of course, they have different way of interacting or solving the problem somehow. This is the main difference between them. We're talking about objects. We're talking about procedures or functions somehow. Now, why we use object-oriented programming in developing software? There's so many reasons that you can find a lot of reasons, but let's summarize the main things that we can use. Okay, the first one is called modularity. Okay, the modularity is that means that in the source code of an object is independent of the source code of other objects, so they are independent of one. If one of the object is deleted from the system or somehow is not working, that will not affect the other codes, probably, yeah, because they are independent. Or you can even replace one of the object with another object. This is what we call it modularity. So there's independency between the objects. Okay, so you can move object inside the system, take it out from the system, replace it, delete it, do whatever you want. This is a very interesting actually property in object-oriented structure. Now the second thing is called information hiding. We call it sometime encapsulation. Encapsulation meaning hiding the information from other object. The system has more than one object. That does not mean they are separate, they are independent, but each one has a private data, what we call the private data. It will not be shown for other object or other program unless they have some kind of level to know the data in that object. Interact between object through the methods. Okay, this method will be implemented internally inside the object. So in order for each object to interact with the other object, he has to create a method in order to give him what he wants from the data that he hold or something like that, because it's all private to him. These are, so we said, modularity and information hiding. Reusability is very interesting one. Instead of writing the code all the time, you just write the code and you can use it many times in the same program, or you can use the same code in another program as well. So basically it's a very interesting code that you write general code not for a specific purpose. It does some task, but you can, instead, when you create a new program, instead of writing the code again and again, you just reuse the old code. That's a very good. We call it reusability, or some people call it recycling. okay? But in programming, we call it reusability. Pluggability and debugging is it's this one is for developer is a very interesting one, okay? So if there's a problem in one of the objects, okay, basically you can remove that object from the application, or you can, you know, debug that object and see exactly where is the problem, or you can replace it with another object and so on. So you can you know, do something and trace the problem and try to fix it, or if it's not fixed, you can somehow replace it with another one. It's more like, you know, if you have a car, okay, and a tire just, you know, gone on the road, and you can just replace it with another tire. It's very simple and easy. This is the real example of pluggability and debugging is. So modularity, which is mean independency, sorry, information hiding, which mean encapsulation, reusability, which mean write one code and use it in different program. Pluggability and debugging is if there is a problem with an object, you can just remove it or replace it, or you can trace the error and try to fix it. We study why we use object-oriented programming, but what is the meaning of OOP? First of all, OOP always stands for object, because it uses object-oriented programming. Now, object-oriented programming is the main focus on it, the main focus on it objects. So it is about creating objects, okay, and contain data and functions inside that object. Sometimes we call it a property and methods, or we call it attributes and functions, different names. But anyway, it's about creating an object and contain some data and methods inside that object. Now, object-oriented programming, as a formal definition, it's a methodology. It's a methodology to design what? A program or software, you can say, using what? Object. You see, the main focus is in object, and that object should contain what? Data. So you create an object, okay, and this is an object, all right. Inside the object, you will have data, okay, this is data. Sorry, I'm gonna write it this way. And you also have what? Methods, or what we call it function, or sometimes we call it behavior, okay? So you have methods, all right, inside each object, and you have another object here, you have another object here. It's not just one object, so at least you will have one object. Now, inside in the programming language, we have a classes and we have object, okay? So these two terms, class and object, are the main things in object-oriented programming. Because what? Because we create an object, the class is just a template for the object, it's just a blueprint for the object. We will see an example later on. And the object is an instance of the class. For example, we say we have a class called car, all right? But we create an instance object from the car. We call it a Toyota, we call it Kia, we call it Chevrolet, we call it whatever you want, okay? Brands of the car. So the main template is car, and we have instance object that we can create or take from the car. This is a real example, okay? So objects is autonomous code that can be interact with each object, with other objects to solve the problem. Now, this is the main component, or or the main concept, you can say it, in object-oriented programming. So we're going to look at the object. What does it mean? Class. What does it mean? Polymorphism, encapsulation, inheritance, abstractions. There's more, but in this course, we're going to focus on these six concepts, okay? Let's just understand them, and the other advanced concepts will be easy for you to understand maybe in another course. Now, let's talk about object and class. We say that object-oriented programming is about what? Is about object and class. So object and class. All right. What is the object? We say the object is an entity. All right. That has what? That has two things. Property, we call them sometimes attributes or data, and behavior, which we call them sometimes what? Method. All right. So any entity has attributes and behavior or methods. We call it object. For example, a chair, a pen, a table, a keyboard, anything around you. Look at the real world. Okay, anything around you is considered as an object. We took this concept from the real life and we apply it on object-oriented programming. Now, another example is a car. Okay, the car has properties or attributes such as the color, the model, the brand, the engine size, and so on. How many seats and the weight and so on. The plate number and so on. All right, and it has also methods, or we call it behavior, such as speed, move forward, move backward, stop, and so on. All right. So the object could be a physical things really exist in the real life, and it could be logical. All right. It could be a logical things, or it could be a physical things already exist in real life. All right. Now, if we say the class is a template that define the object. We say we have an object has a color and a model and has a behavior called moving forward or moving for backward. Now the class will draw the main structure of this object, define the object exactly. So we can say the class is a logical entity. It's not a physical. The object could be logical or physical, but the class only logical implementation for the object. All right. So it could be a blueprint or a template or a prototype for the object. All right. This is an example here. So we can say that we have a class called student, and the student has name, has roll number, and there's two function or two methods, set name or set roll numbers. This is a class, and we can create, this is a blueprint. Blueprint means a template. We can create many objects from this class. We call it instantiation. Create an instance from that class using, meaning we creating a new object. Okay, so for example, we create Nancy and we gave her the roll number 1999. We created James, we created Lodi, we created Gabby. We can create many objects from this template. All right, so basically the main idea between object and the class, because they are the main core in object-oriented programming, class is a template for object. All right, an object is an instance from the class. All right, you cannot take an instance from an object. All right, the instance comes from a class itself. This is the main difference between object and the class. Encapsulation, as I said, encapsulation means hiding information. Look at the picture here, talking about capsule. This capsule contain, we imagine it as a class or an object. It contains method and variable inside it, hidden inside it, okay? And hidden inside this capsule, all right? This capsule could be a class, which we can create an instance from this class, many objects, okay? An official definition for it, it is a mechanism for wrapping the data, hiding the data, all right? And the method as well, of an object into a single logical unit, which is a class. Okay, a Java class is an example of encapsulation. All right. Now, the fourth things or the fourth concept is called inheritance, because we have so many classes. Okay, and each class is a template for an object, and they have separate data, separate object, but they need to interact with each other in order to solve the problem. All right, So it is similar to the inheritance from your parent. Okay, so we have parent, mother, and father. They have genetic properties, and the child will inherit all the property, the skin color, the some of these genetics things from his mother, others from his father. All right, so he will get a mixed property. Sometimes you'll get everything from the father and some of the mother and so on. So this is called inheritance. Same thing in real life, which is inheritance from a parent, applied on the between classes. So a class is capable of inheriting property from other classes. All right, when you talk on abstraction later on, we'll know how does that happen. Okay, so we have a parent class and we have a child class, or we have super class and we have subclass. Okay, when we say parent class, it contains most of the method, and child class will inherit all the data and all the methods inside that class. All right, so it looks like we have the parent class, all right, and we have subclasses. All right, if you have anything here, anything inside this, it will be inherited by the child classes. Right, this is just inheritance. We'll practice that later on. Polymorphism, very easy. A good example for polymorphism, we can see that we have a human, we have birds, we have cat, we have dog, for example, as seen in the picture. They all have voice, right? But we have different voice for each one. They all what have voice. Okay, we call it voice, but the voice had different format. So the human speak, the dog bark, the cat meow, the duck cow, or something like that. So that means polymorphism mean we have many forms for the same class. As an example, on off, it's just a button. Okay, but it has two forms, on and off. Okay, same thing for the class. We have a class, but this class has two forms. For example, we have shape, and the shape has rectangle, have triangle, and so on. Has many shapes. All right. Now abstraction is something called, you create an empty class that contain no method and no data. If it's contain data and contain method, this method has no code. So you create a class that has an empty code, for example. This is an example. So we create a class called calculate shape. All right, and it has two methods: calculate area, calculate display. But the shape, we have many forms. We have rectangle, we have circle, we have triangle. If we want to use this, these all inherit the same function from the shape, is that okay? But if you want to use calculate the same function for all, that's wrong, because the area calculation for rectangle is different from circle, is different from triangle. So we have put abstract function. This is an empty function. Okay, the implementation will be here for each one different. For the circle is different, for the triangle the calculation area is different. All right, but the display might have also, you want to display here the rectangle in different way, the circle in different way, and so on. This is another example of abstraction. All right, so you create an abstraction, and polymorphism are more related to each other. All right, so we have how many concepts now we talk about? We talk about object, class, encapsulation, inheritance, polymorphism, and abstraction. So we're gonna learn object-oriented programming using Java. What is Java? Java is a very interesting language developed by Microsoft Sun. It's owned by Oracle now, and it runs on all the platforms. Okay, it is used to create web application. It's used to create it's used for testing, used for create mobile application, used for big data, used for framework, used for games, used for desktop application. It has many interesting in an area that can be used in. So it is a very developed and interesting country. It has a huge library that can be used in any area. This is why we everyone is using Java. All right. Now, why we use Java? It is very simple and easy to learn. It's similar to other programming language. If you know C or C++ or C Sharp or even PHP, all right, it's easy for you to learn Java. It's object oriented, which is the most important thing, because the code is you use object, and so we can depend on modularity, reusability, and the cost of developing any application will be lower than any other languages. It's platform independent, and it's also portable, so you can write the program. The same program will be run in any platform you want. Okay, that we have a say in Java saying write the code once and run anywhere. Robust, it contains a huge library and a lot of services like memory management. You don't have to worry about the memory because they have garbage collection. It provides exception handler mechanism. It's provide tracking, debugging, compiling, Java virtual machine. It's a very robust language. It will last forever. Okay, secure, because it check the error, interpret, check the error before the execution, and even after the execution always check the error using the compiler. All right, it is very interesting. Multi-threading, it use multi-threading would allow you to write a program to do many things simultaneously. So you do a lot of things at the same time in the same program, which is called multi-threaded. We don't know how to do multi-threaded. High performance, you write a Java which converted to a bytecode, basically will be translated directly into a machine language, all right, which is a machine language. It's the language that the machine understands quickly, and it run fast. We're using just-in-time compiler. Very interesting language. This is why we use Java. Simple, object-oriented, portable, platform independent, robust, secure, multi-threaded, and with high performance language. And if you search more, you will find many reasons why people use Java. All right. This is the main phases of writing a Java program. You can open any editor. All right, you can write the Java code which ended with .java, which is the most important thing. You always save it .java and you name it whatever you want. After you write the code, you can do the compiling by simply running Java C. So Java C compile the program and convert it into what we call it bytecode. The extension for bytecode is .class. All right, the last step, which is Java run, to run the program using Java, the name of the program, without any extension. All right, without any extension, and you will get the output. This is the main phase, three phases: edit, write a program, compile the program, and then run the program. These are three steps of writing a Java program. Java development kit, I'll talk about it in general. Okay, it is a software development environment used to develop Java application and applets. Okay, it's include Java runtime environment, loader, interpreter, compiler, document generator, and other tools also in Java. So this is an example. For example, it has Java virtual machine, set of libraries, and GRE, and also you have development tools that you can use: a compiler, interpreter, or documenter, and so on. We will learn. I'm not gonna say too much about this because you're gonna practice this in the future. But we will stop in Java Virtual Machine, and in the next part we'll talk about Java Virtual Machine in general. All right, and then we can continue after that into Java.